Right now, without you doing anything, your phone knows where you are, not roughly, to within a few steps. You open the map and there you are, a small blue dot on a whole spinning planet. I want to show you how that actually happens, just you and me, because it is stranger and more beautiful than you would ever guess. And by the end, you will understand it better than almost anyone you know. Let us start with one simple idea. Imagine I tell you a single fact. You are exactly 500 kilometers from Paris. On its own, that does not tell me where you are, but it tells me something. You have to be somewhere on a circle, drawn around Paris 500 kilometers out. One distance and the whole world shrinks to a single ring. Now I add a second clue. You are also 400 kilometers from Berlin. 2 rings and they cross in just 2 places. So I add a third. You are 300 kilometers from Rome. 3 rings now and they meet at exactly 1 point. That point is you. 3 distances and you are found. Out in space, the rings become spheres, but the trick does not change. This idea has a name, trilateration, and it is the whole beating heart of GPS. So the real question becomes this: how does your phone know its distance to something all the way out in space? Here is the clever part. It does not measure distance at all. It measures time. More than 20,000 kilometers above you, a satellite is calling out one thing over and over: the time. It says, "This message left me at exactly this instant." Your phone hears it a tiny moment later, checks its own clock, and finds the gap between them. Because distance is simply speed multiplied by time, and the speed here is the fastest thing in the universe, the speed of light. Now, light is fast, almost unimaginably fast. In 1 nanosecond, a single billionth of a second, light travels about 30 centimeters, roughly the length of your foot. So if your phone wants to find you to within a few meters, its sense of time has to be sharp to within a few billionths of a second. Be off by just 1 millionth of a second, and your little dot leaps 300 meters down the road. This is why every satellite up there carries an atomic clock. A clock so impossibly steady it would lose less than a second in millions of years. But there is a problem hiding in here. The satellite has a perfect atomic clock. Your phone does not. Your phone has a cheap little clock that is always slightly wrong. And if your clock is wrong, then every distance you calculate from it is wrong too. So think about what your phone is really trying to find, not 3 unknowns. 4. Where you are, left to right, forward and back, up and down, and what the true time is. 4 unknowns need 4 answers. And that, right there, is why your phone never listens to just 3 satellites. It listens to at least 4. With the 4th, it can solve for its own clock error and lock all 4 numbers at once. Your phone is quietly doing algebra several times a second just to draw 1 dot. And now the strangest part of all. The part almost no one knows. Those atomic clocks in orbit do not tick at the same speed as the clocks down here with us. Einstein told us why in 2 different ways. Because the satellites are racing around the Earth, their clocks run a little slow, about 7 millionths of a second lost each day. But they are also high above us, where Earth's gravity is gentler, and up there time runs a little fast. About 45 millionths of a second gained each day. Put the 2 together, and every satellite clock runs ahead of ours by about 38 millionths of a second every single day. That sounds like nothing at all. But remember, at the speed of light, time is distance. 38 millionths of a second is about 11 kilometers. So if we simply ignored Einstein, your blue dot would drift further and further by around 10 kilometers a day until the map was useless by lunchtime. GPS only works because we build relativity right into it. Your phone is holding Einstein in the palm of your hand. So let us watch the whole thing now, all at once. A constellation of about 30 satellites circles the Earth, each one endlessly calling out the time. Your phone quietly catches whichever ones it can hear, at least 4. It reads their messages, learns exactly where each satellite is, measures those tiny delays, corrects for the bending of time, corrects for the shimmer of the atmosphere, and solves for its own place in the world. Then it does the whole thing again, and again, several times every second, and you feel none of it. And here is the part I love the most. The satellites do not know that you exist. They are not watching you. They are simply calling the time out into the dark, to no one in particular. It is your phone in your hand that listens and works out quietly that all of this was about you. A whisper of light crossing 20,000 kilometers of empty space, corrected for the weight of gravity and the speed of time itself, just to place one dot on one map for one person. You are here. You were always the one it was looking for.